Okay, great. So now we're at number 4 in the Intro to Vectors worksheet that you've been working on. I encourage you to make sure you really understand number 3 before you go here and watch the screencast. Make sure you really get the idea of components and play with that piece of software that we were playing with before. Anyway, here's number 4. And in number 4, we see the power of the components in order to do things with these vectors. So here we're going to have 2 vectors. One I've labeled vector C, 17 newtons at an angle of 25 degrees south to west. Should sound familiar. Anyway, vector B is 4 newtons north, which is much smaller than 17. So the first thing I'm going to do is just go ahead and draw these 2 vectors to get a sense what's going on. I've made this be vector B, so it's a pretty small vector going north. This is a 4, hard to read my writing there. Anyway, this is vector C, which is at 25 degrees. It's a length of 17, but notice I don't have the 17 marked here because we're not going to use that 17. What we really care about when a vector is at an angle, if we're going to do something with that vector, is we care about its components. So I haven't shown it, but I already did the math here of finding the west component and the south component for vector C. And the question this time is to add vectors C and B. So we're going to take vector C, we're going to add vector B, and we like to create a new vector that's the sum of those 2 vectors. We're going to call it Y. So we take the tail of this vector B and put it onto the red one, and you'll notice that 4 doesn't even come up to horizontal. So how do we think about adding these 2 vectors? Well, the first thing we notice is that B, being only north, isn't going to change the west and south, the west and east at all. The west and east is going to stay 15.4. Adding a 4 north will not change the 15.4. So my new vector, which I'm doing down here, vector Y, it has 15.4 going west because that component of vector C is not affected at all by vector B. And that's the beauty of using the components. On the other hand, the 7.18 that's going south is going to be affected by a 4 north. In fact, it's going to be canceled, and so that we're left with only 3.18 going south. So we had 7.18 going south. The 4 north cancels part of that, so that I'm left with only 3.18 going south. So these 2 components in blue represent Y. It represents the components of the vector Y. And so I get the 15.4 by looking at the westward component of C and the fact that B has no west or east. That gives me the 15.4. I get the 3.18 because I looked at 7.18 south being canceled by a 4 north to some degree, leaving only 3.18 south. And now what I'm left to do is figure out, well, what does that mean? What does it mean to be 15.4 west and 3.18 south? So we solve this new triangle that's in blue, and we're trying to find both the length of this black vector and the angle of this from west. So what we do is we do a little Pythagorean theorem on the 2 blue numbers, and we get 15.7. And so we have the length of this black vector is 15.7 newtons. Notice these are all force vectors, so we're using newtons. N means newtons. Finally, to get that angle, we're going to do arctangent again. So we do the opposite, which is 3.14 divided by the adjacent 15.4, and we divide those 2 and do the arctangent. Make sure your calculator is in degrees, and we get 11.7 degrees. This is going from west. So we call this 11.7 degrees south of west, where this blue west vector, since it's on our little compass, I've done the little compass in green here. Since this is west, we're going south of west, 11.7 degrees. And that's number 4, our first vector addition problem that we did that has the interesting components and very, very powerful ideas. Good luck. Take a look at it again. Make sure you understand how to do number 4.